A multiplicative identity is something we multiply by that does not change what we are multiplying. For matrices, a multiplicative identity looks like this. It has a diagonal of ones, and the rest are zeros. A multiplicative identity must be a square matrix. The two examples here are a 2 by 2 and a 3 by 3. If you multiply a matrix by its identity, you get the same matrix. For example, this matrix, 1, 2, 3, 4, is multiplied by the identity, and the output is exactly the same, 1, 2, 3, 4. Now, why is that important? Well, we use an identity matrix to figure out if two matrices are inverses of each other. Notice here we have a 3 by 3 multiplied by its identity. We get the same output. So why is that important? Well, the product of a matrix and its inverse will give you the identity. So notice here we have A inverse A, and the identity matrix 1, 0, 0, 1 is the output. You can represent a system of linear equations with matrices. So notice the coefficients 3, 5, 1, 2, and the constants 7, 2. Notice if I were to multiply this 3 by this x, I get 3x, 5 times y, 5y, and the output is 7, which would be in the first row, first column. And then the same for the second row, 1 times x, 2 times y, and the output is 2. So this matrix product is equal to the 7, 2, and will represent this system. We can use an inverse to solve that system. So the matrix on the left, A, the inverse is 3, 5, 1, 2. The matrix is 3, 5, 1, 2, and its inverse was 2, negative 5, negative 1, 3. If I take this matrix and multiply it by its inverse, I will essentially get rid of this matrix because the output then would be a 1, 1, 0, 0, 1. So to do that, I'm going to multiply this equation by the same inverse. So this inverse is going to be multiplied on both sides. So notice on the left we have the inverse, and on the right we have this inverse. If we multiply these two matrices, the output on this side will be 1, 0, 0, 1. On this side it will not be 1, 0, 0, 1, but it will be the solution to this system. So on the left, A inverse A. On the right, we call this A inverse B. This is a separate matrix. And so the output is an identity on the left, and it's the numbers 4 and negative 1 on the right. Since multiplying 1, 0, 0, 1 by xy just gives you xy, we can say that x and y are 4 and negative 1. So the solution to this system that we started with is 4, negative 1. Now let's try the same thing with a bigger matrix, a bigger system. We have a 3 by 3 system, and we call it that because it has 3 variables and 3 equations. So let's take these 3 variables, 3 equations, and let's set up a matrix equation. The matrix on the left we call coefficient matrix, have these numbers that are in front of our 3 variables. And the matrix on the right has our constants, negative 26, negative 12, and 15. And then the variables go in the middle. This is our variable matrix. To solve, we need the inverse of this matrix. And we've learned some methods for finding inverse of a matrix, but I'm going to show you a method you'll probably like better, and that is the Desmos matrix calculator. So let's take a look. In this matrix, I have typed matrix A and matrix B. So let's find matrix inverse. And look how awful that is. But really, we don't need to type that or even write that when we solve a system, because we know matrix A inverse A is going to give us the identity, and A inverse B is going to give us the solution. So right here, I have the solution, negative 2, 1, and 5. So again, we multiplied the left side of this by its own inverse, and we multiply the right side of this equation by that same inverse, and the result is the identity on the left and negative 215 on the right. So that's telling you that the variables x, y, and z are negative 2, 1, and 5. And that is the solution to the original system of equations that we were given.